How the things are behaving. That is the only way you can know. Otherwise, like the n factorial, how are you supposed to know it's n factorial? Just look at how the numerator is moving. So 1 factorial, 2 factorial, now we have 6, that is 3 factorial, 24, that's 4 factorial. So the next one will be 5 times 24, 120, that is 5 factorial.
So can you first differentiate, like define factorial? The definition of factorial?
It is very simple. N factorial is the same as n times n minus 1, n minus 2, and you keep on multiplying until times 1. Then we know 1 factorial is 1. 0 factorial is also 1. So 3 factorial, for example, 5 factorial is the same as 5 and 4 and 3 times 2. That is factorial. We have done it in when we were doing binomial. So 5 factorial, I'm sure it's 120. Okay. And now the next thing that we need to do is the application.
Which one?
The note. Yesterday note.
Math. No, I'm not.
You didn't sign.
The one taking a picture. Yeah, I did.
Applications of differentiation. And then we start with the first one is the tangent phenomenon. Okay, so let's say you are at point P, whose coordinate is x1, 1, 1. And now, what is the tangent line of a curve at a certain point? What do we mean? If I'm talking about tangent of a curve at a point, what am I talking about? The tangent line of a curve at a certain point. What is it? The normal. A straight line that it passes through the point. So you mean a curve can have more than one tangent line, so you can have so many, infinitely many. Any line that passes is tangent.
The line that shares the coordinate with the curve.
Yeah. Which is the same thing that we said. Share the coordinate means it goes through that point, isn't it?
No, it doesn't go through to the exact.
What is a tangent line, people?
It's a line that passes the circumference of the sun.
Hey, what?
It's on the circumference.
Are you from?
You are now thinking of circumference, then you mean it. If you can work out like if a curve is a circle or an ellipse, then you can work out the circumference. But in this case, my friend, in this one, you might never not be able to. It's an infinite curve. It goes continuous.
Okay.
Yeah, no, you can't.
So it's a line that lies
It is
on
a line
boundary.
that touches the curve only at that point. So it only touches the curve only at that point. So like this curve will only have one tangent line.
Yeah.
So that is the tangent line And what is a normal? Tangent only touches the curve at that point. And then what's a normal? If you don't know what is a normal, you will curve at the point. Normal line is the line that is perpendicular to the tangent. So that should be perpendicular to the tangent. Okay, now we have to look at how to do the calculation. So okay. So in the case if you have y part f of x, you just substitute the x coordinate into the derivative, then you get the gradient of the tangent already. Hello. And then come here, let's fight.
No?
I know who's gonna win.
Can you fight?
No, so I can't.
Why I like it?
So the thing is ahead of part-time job, but today was my last day.
So you were putting your things together
Yes.
and you're getting your pension. I will talk later then. But today you are a rich man, huh?
I'm not.
So what I'm talking about here is that there are two possibilities. If you have only a curve which is explicitly defined, like y is equal to f of x, then you just substitute the x coordinate into, because the derivative will just be in terms of x. So you take the x coordinate of the point, substitute into the derivative, then you get the gradient of the tangent. If it is an implicit function, then you need to substitute both x and y.
What's the meaning of that line there?
Substituting it, 8.
Oh.
dy dx 8.
Oh.
Yes. Let's look at maybe just an example. I think will make it much understandable.
So,
Yeah.
did you solve that question?
Question.
Cos x squared.
Forgot. Maybe you can show it too. Maybe let me just say find the equation. Let me erase gradient. Equation to be even much better. Because for the equation you have to go through the gradient as well. Okay? So work out this one. So first we need the gradient, isn't it? Gradient. So we must differentiate. Give me the derivative of that.
2 cos 2x 2x cos 2x.
So that is the derivative. So the gradient of the tangent it will now be given by, so the derivative when x is equal to pi, and that means that you substitute pi into the derivative. Because there's only x there, so you substitute only the x coordinate, and what do you get?
Did you say?
2. You get 2. So the gradient of the target at that point is 2. And then the y coordinate, we need it, because now we are looking for the equation. So the y coordinate is now y is equal to sine. At that point was because that is the point where x is pi. So we substitute pi. And what is sine 2 pi equal to? 0, isn't it? Sine 2 pi is 0. Sine 2 pi is 0. Sine n pi, where n is an integer 0. Okay, so the point, that means the point is pi 0. So the point is pi 0, and therefore the equation of the tangent of the tangent will be, you know, y minus y1 is equal to m x minus x1, and then you have it, so y is equal to 2x minus 2 pi. So that is the equation of the tangent at this point for this case. So if you were to sketch this curve, you don't have times 2x. So it means that we have a half cycle here. Supposed to be like this. Then now it will just be I can't draw it anymore. I forgot. But you can draw it. That is your homework. Draw it. Okay, maybe let's look at number 2.
So, what does dy over dx in that line, the x equals pi mean? What does it mean when you write it like that?
What?
What does it mean when you write dy over dx in a line?
Did you just say
X
dy over
equals.
dx?
No, the way you
I'm
wrote it.
asking,
Yeah, I did say.
did you say dy over dx?
Yeah.
I would deduct the marks from
No, sir.
I will deduct the marks from your next.
No, I know what you mean. Like,
Yes, what I mean.
next to it, x equals pi. Do you mean the precise value of x equals pi, or
You are substituting x equal to pi into the derivative.
so that
And you
would-
don't read it as dy over dx. It's dy dx. That's why you people are failing. I've been telling you this. You don't read this dy dx. It's not a fraction. It's a notation. It's dy dx. Dy dx. Repeat after me.
dy dx,
Dy dx.
dy dx.
So that even everybody that walks around there will say that, this guy is teaching like he's teaching grade 1 kids, huh? Okay, so here you see this is an implicit function. Eh? So for implicit, it will be different. We have to differentiate and substitute both coordinates here. Let's differentiate. I'll write something and then you tell me if it's right or not. Is that right? You don't agree? What is missing?
So you're not supposed to produce logs.
Just use product.
If you introduce logs, you just complicate it. If you introduce a log, you will have log of this equal to log of that.
You're right.
You don't do anything. Logarithm of a sum, you can't do anything. You're right. You can't see.
Because of the light.
Class representative, People cannot see because of your phone.
Okay, there's a phone blocked on you.
Yeah. It is possible that it's so you have to go like this.
It's smaller than a person's head. Okay. Something is not adding here. So we are doing mathematics and when we look at the
See, people
area.
I say, people don't have peace. Ladies ever angry this way. This semester must come to an end. So that. So okay, but all right, for the final time here, I have written that 3x squared y cubed plus 3x cubed y squared plus 4 equal to 6x. Is that right? I'm differentiating. Is that right? What is missing? dy dx is missing. Where is it supposed to be?
At the middle.
There. Is that all? Now people realize that I left the space here so they know.
Dy dx.
So meaning that if I give you this question, you're still failing. You don't know how to do implicit differentiation. You people are not practicing. I just noticed it now. Because if we do this now, tomorrow we are doing something else. You will forget this totally if you don't practice, if you don't go practice it tonight. You won't remember what you have done today. Okay? Now this one suggests that I have to write. So then now we have dy, we are trying to make dy dx the subject. So it's common in the two terms, and then the other one is that dy dx, I'll move it to the right hand side. This is 3x cubed y squared plus 4. And then we make dy dx the subject of the formula. So that is 6x minus 3, x squared y cubed over 3x cubed y squared plus 4. And then now you can get the gradient of the tangent. Gradient of the tangent will be, so you substitute the coordinates of the point where you are finding the tangent. So that is dy dx at the point 2, 1. So those people that don't understand this, I just mean at this point. This means at that point, yeah? So meaning that wherever there is x, you put 2, and wherever there is y, put 1. So that is 6 times 2 minus 3 times 2 squared, 1 cubed, 3, 2 squared, cube, 1 squared, and 4. See what you get? 12 minus 12 average, that is 0. Now you need to use your cabez a bit. Cabez must work a little bit. Gradient equal to 0. If a line has a gradient of 0, big man, what does that mean? If a line has a gradient of 0, so what kind of a line is that? All lines are straight lines. It is a horizontal line. So what is the equation of now the normal? So the tangent is a horizontal line. So normal will be the normal will be what?
It will be parallel to the y-axis.
It will be parallel to the y-axis, and parallel lines to the y-axis are vertical lines. Okay. So therefore that means
It's a
that here is the
horizontal
point
line.
2, 1. So meaning that x is equal to 2 is the tangent. And then what is the normal? Equation of the normal. Equation of the normal is y equal to 1. Y equal to 1. times y equals to 1. First, you see, this is the point 2, 1. Let's say the curve maybe it's like this. So, no, it's not like that. Maybe let's say the curve is kind of like a parabola. Then you have tangent line there and the normal line here. I'm not saying that the curve is like that, but that's an example. We'll fail this.
That's right. So,
Who will fail this?
how did you find the vertex of that parable?
Hmm?
How did you find the vertex of that graph?
What
Sorry, man.
I said, that's what I just said. That is not the graph of the curve, but I am just giving you an example. That at that point, the tangent will be a vertical line, and therefore the normal is it's a horizontal line, normal vertical line. That is not the curve which is given here. No.
Because the gradient is 0, that's why it's vertical. Horizontal.
Yes. Class representative, go and get an eraser from one of the classes there. I need to erase it. Right. I think there will be no one in this class. Questions? That is how you keep quiet. Like you keep quiet if you understand. When the test comes, you are failing.
I don't understand the statement you gave me on the graph you draw.
The graph,
Right,
the graph is for illustration purposes only.
You said
It is not the correct graph.
Yeah, but you said was the x is equal to 2 is the tangent.
Yes. Because the gradient of the tangent is 0. And I know the x coordinate there. The line you have to go through that point 2, 1, and it is horizontal. So what would the ocabase give you if you think nice?
Okay,
You're not supposed
right,
to.
you know what is
Like,
the
yeah.
one that is two.
The normal is the one that is 5 years Tangent is x.
You are right.
Yeah.
So that should be y equal to 1. Now your ocabase gave you nice things. Yeah, you are right, my brother. Thank you very much. I did it on purpose to see if you would. Now you mean my ocabase is the one that was not giving you that?
Yeah.
Okay. So I take it as this. And if I fail, I take it as fail.
You didn't have faith.
I don't blame anyone.
Say you failed.
People in us, they will blame the lecturer. Any question? Good. There's another mistake. Let me see who will find it out. This guy is not serious, man. No. How many classes did you check?
Those two there.
No, it is. No, yeah, we'll not use this one.
It looks like someone was putting.
How about yours? Wait, down there. Everybody is not serious. We have a vice president up there.
Oh my God.
Do you want me to go and look at other classes?
Yeah, you.
You should. Go to the Eastern classes, the other side.
Instead.
Yeah.
There.
Yeah. So while you are going there, we are doing something. Hurry up. Right.
These guys came.
Hey.
Charles, you're so bad.
Yeah.
Good?
Okay. I fulfilled my assignment, sir.
Very good.
Let's get
Oh, no.
Let's get 2 marks.
That's why I don't ask you.
Where else, sir? I hear. That's 4 marks.
Charles, you are not serious. Okay. So here, derivatives are applicable as well when you are sketching curves. Like